All right, we got page 2 of the sample test, chapter 3, and wants to know when this parabola, this expression, which if I wrote it as y equals would be a parabola, and actually an upside down parabola, when would it be less than or equal to 0? Well, this part is less than 0, and this part's less than 0. And that's if this is the y is less than 0. And to solve it, I need to say for what x's is this part happening, and for what x's is this part happening. So my answer is going to look like, since I know it's an upside down parabola, it's going to go from negative infinity up to that x-intercept, which I got to figure out. And since it can equal 0, I got to make a including bracket, union, and then it can equal 0, including bracket from this intercept, x-intercept, to infinity. Now, if it asked for when it was greater than or equal to 0, I would have used the in-between part on this parabola because it's upside down. If it was right side up and I wanted it greater than, I would use the outsides, and otherwise I use the inside. So all I need to know is what those x-intercepts are, and so I can get those either by factoring or using the quadratic formula. If you don't like factoring, let's go ahead and use the quadratic formula. The opposite of b plus or minus the square root of b squared, well, 13 times 13 is 169, minus 4 times a minus 3. That's minus, 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 which makes a minus. 4 times 4 is 16, times 3 is 48, all over 2a. 169 minus 48 would be 161, 121. That happens to have a perfect square. That is a perfect square, and its square root is 11. So I got negative 13 plus 11. Negative 2 divided by negative 8 is positive 1/4. No, I'll leave it like that. And then I'm going to have negative 13 subtract 11. That's going to be negative 24 divided by negative 8. That's going to be positive 3. So the 1/4 is smaller than the 3, so it must be this one. So everything under 1/4 will be less than 0. Up to 1/4 would make it equal to 0. And then 3 would make it equal to 0. And anything above 3 would make it less than 0. And you can check that by putting some numbers above and below. Okay? 5b. Well, I know this is a parabola, and I know it's going to be 2x squared, so that's a right side up parabola. And in the factored form, I already know what's going to make that be 0. If I set 2x minus 1 equal to 0 and add 1 and divide by 2, I get x equals 1/2. And this one's going to be x equal negative 3. So x negative 3 would be over here on the x-axis. And the 1/2 would be over here. And if I want the part of this parabola that's greater than 0, that would be this piece and this piece. Those two pieces have y values greater than 0. This piece is where this quantity would be less than 0. So I want to go from negative infinity up to negative 3. Instead, it didn't say equal 0, so I can't keep the negative 3, so open parenthesis, union 1/2, open, because I don't want it equal, to infinity. Now you could have gotten the 1/2 and the negative 3 using the quadratic formula, but this one's already factored, so you shouldn't have to. This one would factor because it came out to be nice numbers. 6. The quantity Q of an item is sold is dependent on the price P by the formula. The quantity equals 300 minus 2 times the price. Write a model for the revenue. Well, of course, the revenue is the number sold, quantity, times the price. And it said any model, so I can make it a function of Q or P. Since I know what to replace Q by, it's already told me, this will be will give me a revenue as a function of the price. That's P times this. This goes in for the quantity. P times that would be 300 P. P times that would be minus 2P squared. Determine the price that produces the maximum revenue. Well, that would be the P of the vertex, which is minus B. So A is negative 2. B is 300. And C is non-existent. So the opposite of B over 2 times A is 75. That's the price. So I'm just going to call it dollars. It didn't say what the price is in, so I'll just say dollars just to help you see it. So that's the price that will produce the maximum revenue. Determine the quantity sold at the maximum revenue. So it doesn't say find the maximum revenue. It does here in D, but in C it says determine the quantity. Well, the quantity is 300 minus 2 times the price. So I got 2 times 75. So that's 300 minus 150, which is 150 is the quantity. 150 items. Then finally, what's the maximum revenue? Well, it happens at a price of 75, and so if I plug 75 in here, I will get the maximum revenue, depending on the price. And so I will do the revenue at a price of 75 is 300 times the price minus 2 times the price squared. Or I could just say, there's 75 is the price and 150 items, and I could just multiply those two. And I would get the same answers I'm going to get from this. And let's just verify that. 75 times 150 is 11250. And that's the revenue. But let's do it the other way here. 300 parentheses 75 close parenthesis, subtract 2 parentheses 75 close parenthesis squared, and we get the same number, 11,250. Number 7. I've already put the numbers into my table. Just to remind you where to put that in, there's that stat, stat, and then press enter for edit. And there's the X and Y. I put them in list 1 and 2. And now to plot it, I'm going to turn on my stat plot by going second Y equal. Plot number 1, I want to turn it on. I want it to be a scatter plot. I want it to use list 1 and list 2. I'm going to make it have little crosses. I'm going to make sure there's no equation. And I'm going to go zoom, get my dots to fit, my stats to fit. Zoom stat, which is number 9. And there I see my data. Now it says write the appropriate model for the data. Well, this data, if I look at it, looks curved. So I wouldn't use a linear regression. I would probably try the parabolic or quadratic regression. So to do that, I would do stat, calculate. Number 5 is the quadratic, the parabola shape. And my x's are in list 1, comma, my y's are in list 2, comma, and let's put the regression equation into vars, y variables, function, y1. Enter. And so now it's putting the equation, this equation in there. So I've just come up with the equation y equals negative 0.295x squared minus 0.014x plus 4.703. So I took everything to 3 decimal places. And let's push graph to just see how well it fits. And that's a pretty darn good fit. Now if I'd done linear regression, stat, calculate the linear regression, and use list 1, comma, list 2, comma, and let's put it in vars y variables 2, and I get that equation, and when I graph it, there's the parabola from the first one, there's the line, and it certainly looks like the parabola does a better job than the line. And you're supposed to explain to me which model you chose and why. So you may want to do a little bit of a sketch of what it looks like or something like that, so I know how you decided to do the parabola.